Today we are starting three-dimensional coordinate geometry. And by the end of today, we're going to know how to plot points on a 3D plane and find equations of a sphere. So you're used to plotting points in the Cartesian plane, which is just your rectangular plane, where you have a point A, B, or X, Y. A is the X, B is the Y. And then in three-dimensional space, a third dimension is added. So we plot points of the form A, B, C. The C value is the Z coordinate. Okay, and I'm going to show you in just a second what that looks like, but you do have a picture on your notes below. So observe how the three-dimensional grid is formed. To represent the points in space, you're going to choose a fixed point, which is the origin. And then the three lines that are through the origin are going to be perpendicular to each other. Those are called the coordinate axes. And then you're going to have the X, the Y, and the Z axis. So your point is going to be X, Y, Z instead of just X, Y. Now I really like these pictures because I like how they show you how it relates with the planes and then in terms of a room. Okay, so I like to think of planes as like a piece of paper, right? It's going to be straight up and down like a wall. So of this room, the left wall is the XZ plane. The right wall is the YZ plane. And then the floor is the XY plane. Okay, and look and see how these intersect. I'm going to draw just a rough picture to start, and then we're going to draw some together as well. So your Z is going to be the vertical axis now. You don't have to draw this, you can just watch. Okay, and then your X and your Y are going to be like so. So first I draw my X, and then I know that my Y is going to be perpendicular. It also has to go through that same point, which is the origin. So that's the O that they're talking about, the origin. Now, the positive side of the X is going to be what's in front here. Okay, so this is the positive side of the X, and then behind it is the negative side. For the Y, the positive side is in front here, and then the negative side is behind it. And then Z is just like how we would normally think of our X, where the positive is up and then the negative is down. Now, when you plot a point, you're actually going to be tracing its path, which is what I have here. So we're actually going to highlight that together. So in that picture, it's showing you that what you're doing is going A units on the X. Now those are going to line up really nicely. Okay, when you see the A on the grid is going to be right there. Your B is also going to line up nicely. You're going to be going out to B. But then your last one, your C, is going to be a little bit in front. So like this would be your C value, and that's because we're in three dimensions. So I like to think of this rationale as like when you draw a cube. Okay, so when I was little and I learned how to draw a cube, I learned I would draw a square first, and then I'd put a same size square, except I put the dashed lines now, behind it, and then you would just connect their vertices together, right? You connect the diagonals, okay? So even though this is representing the flat top of the box, okay, see how these are going to be slanted lines here? So it's going to be similar when you're plotting your points on your graph. Okay, and we'll go over some of those strategies together. So for example 1, you're given 2 points, P and Q. The first thing we're going to do is plot them, and then the second thing we're going to do is find the distance between them. Now to find the distance, you do have your distance formula in 3 dimensions. If you remember from geometry, it is going to be the same distance formula. The only difference is now you have the Z dimension. Okay, so it's the difference between the two x's squared. Okay. All right, so let's start with part A, and we are going to start by drawing our vertical axis, which is Z. Okay, now for my x's, I have to go out to 2 and 4. My y's, 9 and -1, and then I have to go up 6, -5. Actually, I might want to even extend that. That's not really as straight as I would like it anyway. It's okay to readjust. I think so. Just because I like things done the right way. I do like things done in a particular way. I have a very particular set of skills. And my y has to go out to 9, so I actually might even extend that a little bit more. Okay, and then I'm going to help you make your units. So your units are going to be parallel to your axis. Okay, so for x, this could be 1, 2, 3, 4, 5. 1, 2, 3. Okay, and then for my y, these are going to be parallel. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And that would be -4. Kind of looks like an old TV antenna. I don't know if you guys would even know what that looked like. Okay, and then 1, 2, 3, 4, 5. And if you needed to, just like on the X and Y plane, you could scale different axes by different units if you had to. Okay, so now we're going to plot the points. So the first point, P, is 2. So I'm going to go 2 on my x-axis, so 1, 2 from the origin. Now when I go to the 9, I want to be parallel with the y-axis. Okay, that's what's going to make your picture look really good. Okay, so I'm going to do this in pencil first. Okay, and then I will trace over it. Okay, so this is going right out to the 9. Right, now it's your Z that's a little bit different. So again, because this is in 3 dimensions, your line is going to be parallel to this one. So if I move this up, I'm trying to go to 6, which is right here. Okay, so I'm going to, make sure you watch me. So I'm going to move this line up just to the 6, and then I'm just going to put a little dash line here, and then I'm going to meet these two. Okay, now you're not going to highlight this little dash line, but I do want to see some kind of dash line that represents that you know that this is going to 6 here. And then I'm just going to connect it straight up. Right, and then that is my point P. Right, so again, if you look at the units, okay, it's not going to be just straight out to 5, okay, because it's in 3 dimensions, or 6, sorry. This one's going to 6. Okay, so that's why it is going to be that dashed line. I'm actually just going to leave the 6 there. Okay, how did your first one turn out? Okay. Okay, now let's try Q. So Q, I'm going to go out to 4 first. I'm going to use a different color. Okay, so I'm going out to 4. And then I have -1. So again, it's going to be parallel to this axis. So here's my axis here. I'm going just back 1 unit, so it's going to be really short. Okay, and then I also want to make it parallel to my -5. So I'm just going to do a little dashed line here. And then sometimes what you'll see to show that it's behind the axis is you'll see a little bit of a dashed line there. And there's my Q. Say it again. So again, what I'm doing is I'm making these parallel, and that's what's going to make it have that 3D shape. Okay, so where I do want these dashed lines in there, just keep them with pencil so that you know that's not part of the point. Okay, you're just visually showing me, hey, this should be at -5, which is why I'm doing it at -5. Okay, so this is not at any specific coordinate. So it might look like that mine is at 4, but that doesn't really matter. It's kind of in between those two. That doesn't matter. Okay, what matters is that this is parallel and goes to your point Q. Okay, so now what we're going to do, that was step 1, that was plotting my points and labeling them. Now what I'm going to do is step 2, which is finding the distance. Okay, so the distance is the square root of the difference between your coordinates. So for my x, I have 4 minus 2 squared plus -1 minus 9 squared plus -5 minus 6 squared. Okay, so 4 minus 2 is 2. 2 squared is going to be 4. This would be -10 squared, which is 100, and then -11 squared, which is 121, which will give you the square root of 225, which is what? That's a perfect square. What's the square root of 225? 15. Okay, so the distance between them is 15 units. Okay, you guys ready to try part B? Alright, so try to do that by yourself. If you're feeling lost, you can still watch me. Okay, remember we are starting with your z-axis here. And then x. And then remember these are perpendicular to each other. Okay, so for my x's, I have to go out to 3 and down to -3. So I just want to keep that in mind. So 1, 2, 3. And then 1, 2, -3. Okay, and then for my y, I'm going to have to go back 1 and up 1. So 1, 2, 3, 4. 1, 2, 3. And then for this one, I'm going to have to go up 4 and down 4. Okay, so then I'm going to start with P. So the first thing for P is I'm going to go backwards. So I have to go to -3. And then I'm going to go back to -1. So again, and then I'm going to go down to -4. So before I do that, I'm going to go ahead and dash in where I want to be. So if I'm going at -4, I'm going to take this parallel and go straight down. Okay, and I'm just going to kind of dash that in so I can meet this. Now again, remember if it's behind, to show that it's dropping behind, you'll have a couple dashes for that first part. And that's my point P there. And then let's go ahead and do Q. Okay, so I'm going to go out 3 on the axis. And then again, when I'm going out, I want to make it parallel. So that's the key to getting a nice picture, is making it parallel. So out to 1 and then up to 4. So before I draw it up to 4, I'm just going to take the same line that I had on the X, and I'm just going to dash this out here so that when I go up, I can meet that dash line. Okay, questions for me on this? Okay, so again, where this point is here, like in between what these are, that's not going to matter as much, because see how these are not like all exact spaces? I mean, this is pretty good, but this one is a little bit bigger than this one, so yours might look a little bit different depending on how our spacing is. Okay, so I'm finding this by doing the parallel sides. And then of course we want to find the distance. So this one I just wrote out the work so you guys could see where that's coming from, but really you're going to be doing a lot of that in your head. So 3 minus -3 is, yep, and then you're going to square it, which will be, good. Okay, and then 1 minus -1, 2 squared is going to be 4, and then 4 minus -4 is 8, 8 squared is going to be 64. Okay, so what's 64 plus 36? 100. So this will be 104. Okay, because it doesn't say to leave it as a simplified radical or not, you could either leave it as a simplified radical, or if you want to round to the nearest hundredth, that would be fine too. Okay, so the spacing between these 2 points is about 10.20 units. All right, so we can use the distance formula to find an equation of the sphere in 3D space. Here's your equation for the sphere, and it is going to look really similar to our equation for the circle, which we just talked about in chapter 8, because we had circles that we were graphing in polar coordinates. So in polar coordinates, when we were doing the circle, we did x minus h squared plus y minus k squared equals r squared. This is the same, except now we have the z on it, okay, the z minus l. So just like before, our center was HK, now our center is HKL, and the radius is still going to be R. So for example 2, it says to find an equation of a sphere, and they give us the radius, and they give us the center. So if I'm going to find an equation, what's the only thing I have to do here? Plug it in, right? Substitute. So my center, 6, -1, 2, is going to be plugged in for HK and L. And then your radius is going to be 3. So we'll plug that in for R. So x minus h is going to be x minus 6 squared. And then this is y minus k. So minus a negative is going to turn into plus. And then the last one will be z minus 2 squared. And the radius squared would be 9. Okay, and that's all you have to do for that one. Okay, now, for example 3, we have to show that the equation represents a sphere and find its center and radius. Okay, so if we want to show that this represents a sphere, we want to put it in this format. What's a strategy I can use to put all of this into a sphere equation? What is it? Yeah, completing the square. Remember I told you that we'd get to do completing the square more than one time? Now we can do it not once, not twice, but 3 times. 3 times the fun is what you're probably thinking. So what we have here, okay, we have the x, y, and z squared together. What we want to do is group the x terms together, the y terms together, and the z terms together. Okay, so the first thing I'm going to do is write the x's next to each other. So this will be x squared minus 18x, and then plus blank. And then I'm going to group my y terms. So plus y squared, and then I have 16y plus blank. And then I have the z's, so z squared plus 6z plus blank. And then remember, when you are completing the square, you want to move the constant term over to the other side. So I'm going to subtract 54 from each side. So this would be equal to negative 54. Okay, so remember, if you're moving sides, you do have to switch the signs. Now, I'm completing the square 1, 2, 3 times, which means if I add something to this side, I'm going to have to add it to the other side. So that's going to happen 1, 2, 3 times. Okay, so it'll happen for the x, it'll happen for the y, and it'll happen for the z. Okay, and then Mitchell, do you remember how we find what goes in the blank spot there?
B over 2.
Yes. Yep. Okay, so b over 2 squared. So, Shawan, what's our b over 2 squared for this? Yep. Yep. So you're going to do half of negative 18, so negative 9 squared, which is 81, she said. Okay, and then for half of 16, I'll have 8 squared, which is going to be 64. And then half of 6 is 3, so 3 squared is going to be 9. Okay, do you guys remember why I like to write it like this instead of writing the numbers squared? Yeah, because when you factor it, right, this is going to be the number that you have in your factor. Okay, so this is going to be x minus 9 squared plus y plus 8 squared plus z plus 3 squared. Okay, and then we're going to add all of those together. And what did you guys get? this is what I would do. 64 minus 54 is what? 10. So 10 plus 81. 91 plus 9. 100. Okay, so then my center, remember the form is x minus h. So if you see x minus 9, it's going to be positive 9. Y plus 8 is really, according to the form, which is minus, y minus negative 8. That's why when we pull this out, it is a negative. Okay? So this is like x minus a positive 9. Okay? This is like minus a negative. So you have negative 3. And then your radius is going to be 10 because r squared equals 100. So r will be 10 when you take the square root. Okay, so I'm going to give you some time to quietly do part B. Okay, and then I'll check in with you in about 1 minute. Let's see how we did. So, once you reorganize, you're subtracting the 6 over, which is going to give you negative 3 squared, so you're going to be adding 9. The y squared, because there is no b term, you aren't going to be adding anything, so you can just keep it as your y squared. And then half of 2 is 1. 1 squared is going to be 1 here. Okay, so then when you factor, you'll have x minus 3 squared plus y squared plus z plus 1 squared, and that's going to equal 10. So your center would be 3 and then 0 from the y, negative 1. And then your radius is always the square root of that last number. So you will have the square root of 10. How'd we do? Good? Well. Okay, so then the next thing we're going to do is describe the trace of the sphere. And they give us an equation that represents that sphere. Okay, now I'm just going to draw a rough sketch so that you can think about what the trace of the sphere is. Okay, so here's my sphere. If it's asking you what the trace is in the xz plane, okay, the xz plane, remember, is this wall, okay? So think of this sphere as being cut by a piece of paper there. What's going to happen is it's going to be this circle, okay? So when you cut it, what's lining up with the plane is going to be that circle. Notice how the center of this sphere and the center of this are going to be different. Okay, when it's being cut by the xy plane, the xy plane is below. So it would be here. And I'll just shade this in a different way. Okay, and again, that center is going to be different. Okay, so it's like a piece of paper is cutting it. You actually, if you were in Algebra 2 Honors, the conic sections that you guys studied at the end of the year, you guys did what was called cross sections. Okay, so whenever you do the cross section of a sphere, you're going to get a circle. and then you're going to describe that circle for me. So I'm going to walk you through that process. So in the xy plane, the z value is going to be 0. Okay, in the xy plane, z is going to be equal to 0. So what we're going to do is substitute z equals 0 into our equation. Okay, so our given equation here. So if I do that, I'm going to have x minus 6 squared plus y plus 3 squared plus 0 minus 3 squared, and that's going to equal 25. And then I'm going to go ahead and simplify. So 0 minus 3 is negative 3. What's negative 3 squared? 9. So this is going to be 9 plus 9. So what I want to do is subtract 9 from both sides. Okay, and that will give me x minus 6 squared plus y plus 3 squared equals 16. Okay, and that's when z is equal to 0. This is going to be part of our explanation. So you're going to give me the equation and what you plugged in. Okay, and then you're going to tell me what it is. So it's going to be a circle with radius. What would the radius be of this one? 4. You're going to tell me where it is. It's in the xy plane. And you're going to tell me where it's centered. Now the center is still in 3 dimensions. Okay, so your center is going to be 6, negative 3, and then because you plugged in z is 0, z is still going to be 0 for that part. Okay, so what you're doing is you're describing for me what that trace is. So if you were to even plot this at 6, negative 3, 3, that's where your center would be, 6, negative 3, 3. And then think of a piece of paper cutting that, okay, which is going to be what your trace is. So for part B, based on what we did for part A, how am I going to start this? Yeah, okay, so if it's the xz plane, your y value is going to be 0. Okay, so I want you to go ahead and plug that in and then write your new equation. It's the whole explanation because you're describing it. Okay, so now when you plugged in 0, you got 0 plus 3 squared, which was actually 9 again. So you're going to be subtracting 9 from both sides, just like you did before. And it's going to be x minus 6 squared plus z minus 3 squared equals 16. And that's when y is equal to 0. Okay, and then this is, again, it's going to be a circle. And the radius is still 4. But this is in the xz plane. And the center is going to be 6. And then remember, your y value is 0. And then your z value is going to be 3. Okay, so this whole explanation is going to be your answer. Okay, now the next one is the plane x equals 10. So if x is equal to 10, that's going to consist of all points on the sphere whose x-coordinate is 10. Okay, so all points on the sphere whose x-coordinate is 10. Okay, so instead of cutting it with one of those walls, think about where that 10 is going to be. Okay, if this is your axis, z and x, okay, so 2, 4, 6, 8, 10. What you're doing is you're cutting out this part of it, so this part of your plane, which, again, you think of like a sheet of paper. Okay, so if you cut your sphere, again, that trace is going to be a circle. Okay, it's going to be a circular part of the sphere that you have. Okay, which I know that's rough. Okay, so now for this one, you are going to substitute in 10 for x. So you're going to have 10 minus 6 squared plus y plus 3 squared plus z minus 3 squared equals 25. So 10 minus 6 is going to be 4. 4 squared is going to be 16. So that's what you're going to be subtracting from each side. Okay, so if 4 squared is 16, I'm going to subtract 16 here. I'm going to subtract 16 from here. Okay, and then I'm going to write my new equation. So my new equation is y plus 3 squared plus z minus 3 squared equals 9. And that's when x is equal to 10. So this is a circle. And what's the radius for this one? Now the radius is 3. Okay, and it is 10 units in front of the YZ plane. Okay, because think about it, it's going to be parallel. This is your YZ plane. This is parallel to your YZ plane. Okay, that's the other wall that's not shown. Okay, and it's centered at, so we plugged in 10 for x. We do the opposite here and then the opposite here. Okay, and now we're going to do our story problem. So we have a water tank, and that's in the shape of a sphere, and the radius is 5 feet. The tank is supported on a metal circle that's 4 feet below the center of the sphere, which is shown in this picture, and we have to find the radius of the metal circle. So if you look at this picture, you are going to be finding the trace. Okay, see how this is going to create a circle here? Okay, so what we have to do is find the equation of that circle, and if we find the equation of that circle, we can find out what the radius is. So think of the center here at 0, 0. Okay, so the center of the sphere, you could really choose anything you want. 0, 0 is going to be the least complicated. Okay, so if you think of that as your center, then your equation, and remember the radius of this was 5, okay, then the equation for your sphere is just going to be x squared plus y squared plus z squared equals 25. Okay, that's the equation of the sphere. Right? Now, it tells us that it's 4 feet below. So if it's 4 feet below the center, it's talking about this length right here. Okay, that's 4 feet below. This is vertical. What axis is vertical? The Z. Okay, so if it's below, if this is the center and this is below it, that means your Z value is going to be what? Negative. So it's 4 feet below the center. Z is going to equal -4. And it's Z because Z is the vertical axis. Okay, so what we can do, okay, so if Z is the vertical axis, then what we can do is we can plug that into our equation, x squared plus y squared plus z squared, except we're going to substitute in -4, and then we're going to go ahead and solve this. So -4 squared is going to be 16, so we're going to subtract 16 from both sides. So x squared plus y squared is going to equal 9. This is the equation of the metal circle. Okay, which means the radius would be what?